that aging is due to cells losing their memory. That gene, gene A that was on now gets switched off, and gene B that should be off comes on, and the cells don't work. And we think this is the major reason we get old and we have diseases. And so what we're working on is, how do you flip the reset switch and get gene A to come on again from being switched off? And in other words, how do you make a nerve cell in the brain remember how to be young again? And I think we've made a breakthrough in being able to do that. So there's a couple of ways to do that. One is that there are proteins that control which genes are on and off. There are a set of genes called the sirtuins that we've been working on now for, since I was 25. We discovered these sirtuin genes in yeast cells, and now we find them in our bodies. And they're part of this process of slowing down the change in the epigenome. So we're trying to activate those processes in the body. We can directly activate these enzymes with chemicals. We can also raise the levels of a molecule called NAD. NAD is the fuel, the gasoline, the petrol for these enzymes, which we lose as we get older. So those are some approaches. That's one set. And then the second set, which we've used to restore the vision in blind mice, is a gene therapy. We put a combination of 3 genes with a virus into the eye, and then we can turn those genes on with an antibiotic. We've engineered it that way, so you can turn it on and off just by giving the mouse doxycycline. And then what we get over 3 weeks is that the nerves become young, some of them regrow, and we get the vision back. And the idea there is that we could use either gene therapy to rejuvenate parts of the body, or we could find a way to do the same thing eventually with a pill or 3 pills. But the fact that we can reset the body and get vision back is, for me, proof that the body has a memory of youth and how to reset the system of which genes are on and off.